All right, hi everyone. So today we're going to go over complex zeros. So far we've done a lot of factoring and dividing and finding roots, but everything's been real. So now we're going to talk about / review when it's not real, what that looks like. All right, so you should be on your notes on the page that says complex zeros. And we're going to go through kind of a few methods of how to do this. Okay. All right, so we're going to kind of go down the left side here and practice. I think all of these you can factor them first. All right, so first of all, I notice this one is a quartic, not a quadratic. So I'm going to kind of rewrite this as x squared, because when I raise to a power, I multiply my exponents, minus 4x squared minus 12. And you won't have to do this every time once you get in the habit, but I want to make sure we're good on this. So I'm kind of thinking about something squared, then I'm subtracting it, and then I have a constant at the end. So if I'm going to say u equal x squared. And again, you don't have to go through this entire process once you get the idea, but just to make sure we understand why this works. So I'm basically saying u squared minus 4u, because that's what x squared is, minus 12. And now this looks like a quadratic that I know how to factor, okay? So two numbers that multiply to negative 12 and add to negative 4 are negative 6 and positive 2, okay? But then we know that it's not really u that we care about, okay? We really know that u represents x squared. So I'm going to go ahead and rewrite this as x squared minus 6 and x squared plus 2, okay? So now we know to find the zeros, I'm going to set both of these equal to 0. So x squared equals 6. Now remember, when you take the square root, we have to account for the positive and the negative. So we have plus or minus square root of 6, and that square root of 6 does not simplify at all. All right, same thing over here. X squared equals negative 2 when I set that equal to 0. Square root, and we're accounting for the plus or minus. Now, be careful on this one because I notice that there's a negative inside the square root. Remember that I is equal to the square root of negative 1, okay? So I can really rewrite this as square root of negative 1 times square root of 2, okay? Because remember, you can multiply within square roots. So if I know that this is equal to I can actually rewrite this as x equals positive or negative I, because that's that square root of negative 1, square root 2. And again, square root of 2 doesn't simplify further. So my 4 roots are, and I know there's 4 because this is degree 4. So remember, we talked about this at the very, very beginning, but the degree, which is the highest exponent, should equal how many total roots you have. So x equals plus or minus square root of 6, that's 2 roots, and x equals plus or minus I squared 2, that's another 2 roots. So those are all 4 of your solutions. All right, next we have x to the 4th minus 16. So we did these back in unit 0, that review unit, but these really function again as a difference of squares. So I can rewrite this as x squared plus 4 and x squared minus 4, okay, where that middle term will cancel out. So I'm going to again set this equal to 0, so I get x squared equals 4, square root, and plus or minus, so x equals plus or minus 2, so negative 2 and positive 2. I'm going to do the same thing again right here. X squared equals negative 4, square root. Now, there's a negative inside, so I can rewrite that as square root of negative 1 times square root of 4. You know that square root of negative 1 is equal to I, and you know that square root of 4 is equal to 2. But I'm going to rewrite that as 2i rather than I times 2. So x equals plus or minus 2i. Okay, so my 4 roots are negative 2i, positive 2i, negative 2, and positive 2. All right, next one. This one has 4 terms. It starts with a cubic, so I would first try grouping. Okay, so I'm going to group the first 2 terms, group the last 2 terms, and find the GCF of each. So the GCF of the first pair is x squared, and then I'm left with x minus 2. And then I notice, remember that these want to match. for us to be able to factor, and it already does. So that's just going to be a 1 as a GCF that's factored out. So my two factors are x squared plus 1 from those terms in front there, and then x minus 2. Remember, you should have 3 roots for this one. So when I set this equal to 0, I just get x equals 2, no positive or negative because it's not squared. And then I'm going to do the same thing here. X squared equals negative 1. Take the square root, plus or minus. Now we know what the square root of negative 1 is. That's equal to I. So x equals plus or minus I. And x equals 2. All right, let's go to the next page and let's do number 9. So this one kind of has a little bit of review. It says list all possible rational zeros, then find all zeros. All right, so remember plus or minus p over q, where p is the factors of the constant and then q is the factors of the leading coefficient. All right, so for the factors of p, 20. So 1, 2, 4, 5, 10, and 20. And then over 1, 2. And make sure we want to list them out completely. So what I mean by that is plus or minus 1 over 1 is 1, plus or minus 1/2, 1 over 2, plus or minus 2, because that's 2 over 1, and then 2 over 2 we've already done, plus or minus 4, 4 over 2 we've already done, plus or minus 5, plus or minus 5 over 2, plus or minus 10, we've already done 10 over 2, and plus or minus 20, and we've already done 20 over 2. So those are your possible zeros. Or your possible rational zeros, excuse me. All right, so then I'm going to look at what I have. I'm going to first try and factor it. If it factors, that's going to be your friend because that's going to make your life a lot easier. If it doesn't factor, then you're going to have to try some of these possible rational zeros to see if you can get it down to a quadratic that you can factor or use quadratic formula on. All right, so I'm going to try grouping here because remember that's my first go-to when I have a cubic with 4 terms. So I have x squared 2x minus 5 and then plus 4 2x minus 5. And that does work, okay? Now, something to note is that not every cubic with 4 terms will factor by grouping, just like every quadratic doesn't factor. So that's when you would have to try a possible rational zero. So I'm going to rewrite this as x squared plus 4 and 2x minus 5. I'm looking for 3 total roots because it's degree 3. I'm going to set this equal to 0, so 2x equals 5 and x equals 5/2. And we actually already did we do x squared plus 4? No, yes, we did do it on the previous page. So x squared equals negative 4, take the square root. So that's going to be square root of negative 1 times square root of 4. So x equals, don't forget your plus or minus. This is 2, and this is I. So those are your 3 solutions. All right, so now we're going to kind of go backwards, okay? So on these, I gave you the full polynomial, and I asked you to find the zeros. Next, I'm going to give you the zeros, and I want you to find the polynomial, okay? So we're going to go down the left side again. This is just on the next page. So this one says the zeros are 1, 2, and 5. So the key is to first write this in factored form. All right, so if it's a positive 1, x minus 1, x minus 2, and x minus 5. And again, that's factored form. If we want to get it in standard form, now this one doesn't specify, but it will likely specify that it wants it to be in standard form. That means it needs to be all multiplied out. So I'm going to first just choose 2 to multiply, and that gives me x squared minus 3x plus 2 when I multiply those together, FOIL or box. Then I'm going to take this, and I'm going to not forget that I need to multiply that by x minus 5, and I use a box for this. So x cubed minus 3x squared plus 2x minus 5x squared plus 15x minus 10. All right, then I just need to combine like terms. And there you have your final answer with those zeros in standard form. All right, next one. Now, I'm not going to take the time to multiply out all of these because I think we can multiply polynomials, but I'm going to remind us how we set all of these up. So 3, I'm just going to leave in factored form. You can multiply it out on your own. And then I will go ahead and multiply out number 5 because I want to make sure we know how to do it with the square roots. All right, so this will look like x plus 2. I'm going to go ahead and do this one next. X minus 2. And then, all right, for negative 4/3, we could write that as x plus 4/3, but we don't want fractions in our roots. So think about what, if you set it equal to 0, would give me negative 4/3. So that's going to be 3x plus 4, because let's think about this. If I did 3x plus 4 equals 0, I would minus 4 from both sides, so 3x equals negative 4, and then divide by 3. So x would equal negative 4 over 3. And again, you would just multiply these out. I would do these two first because you know that's going to be x squared minus 4, and you'll have some cancellation of that middle term. All right, number 5. All right, so same thing here. F of x equals x minus 2 square root 3, x plus 2 square root 3, x minus 1, and x plus 1. So that is it in factored form. All right, here's my kind of hint, suggestion, is the ones that look similar. I know it's not very specific, but like these two go together because they're both positive and negative square root 3, the ones that are opposites of each other. Multiply those together first because like the x plus 2, x minus 2, you're going to get some cancellation going on. And it's going to make it a little bit easier to work with. So I'm going to go ahead and do the last two. That would be x squared minus 1 because that middle term would cancel out. That's a difference of squares. And then for this one, I'm going to do a box over here. Okay, so we have x minus 2 square root 3, x plus 2 square root 3. So x squared, now these middle terms again will cancel out, would be positive 2 square root 3x and negative 2 square root 3x. And then we have to multiply them. So 2 square root 3 times negative 2 square root 3. So to do this right here, you're going to multiply the coefficients, which is 2 times 2, it'll be negative. Okay, so negative 4. And then I'm going to multiply square root of 3 times square root of 3, which is square root of 9, which is 3. So negative 4 times 3, which is negative 12. Again, multiply the coefficients, then multiply the square roots. So I get x squared minus 12. Then you're still not done. You need to multiply those two things together, okay? So that will turn out, you can use a box, you can use FOIL, that will turn out to be x to the 4th minus 12x squared minus 1x squared gives me negative 13x squared plus 12 because negative 12 times negative 1. Okay. All right, next we're going to deal with a little bit of multiplicity. So first, dealing with how we write these. So again, writing in factored form first. X minus 3 is the root of 3. Then it says multiplicity 2. That means it occurs twice. So you're really multiplying it twice, which I can represent with an exponent because it's x minus 3 times x minus 3. And then x minus 5. Now, notice here, this does not equal x squared plus 9, okay? This is really representing x minus 3 times x minus 3, which is x squared minus 6x plus 9. So don't just square the first term and square the last term. Bad. All right. Then I have times x minus 5, which I will need to multiply out in a box. So 3 by 2. X squared minus 6x plus 9 and x minus 5. So x to the 3rd minus 6x squared plus 9x minus 5x squared plus 30x minus 45. So then when I combine like terms, I get x cubed. Let me write my f of x in front. Minus 11x squared plus 39x minus 45. So biggest mistake you'll make there is you'll write the multiplicity, but then just make sure that's really represented as x minus 3, x minus 3. All right, so let's go to the back page under complex zeros, okay, conjugate root theorem. So you may have heard before in either Math 2 or Math 3 that imaginary roots come in pairs. So you can only have 0 imaginary, 2 imaginary, 4 imaginary, 6 imaginary, etc. Okay, you cannot just have one imaginary root. That's not possible. All right, so if a polynomial function has a complex zero at a plus bi, then it also has a complex zero a minus bi. Okay, so again, they're going to come in pairs, they're going to come together. So we're going to we'll do all of them in factored form, but then we're only going to multiply out a couple of them. All right, so this 3i is really 0 plus 3i, if you're thinking about it in a plus bi form. So then the conjugate would be 0 minus 3i, or just negative 3i. So I have 3 roots, 3 total roots here, 2 imaginary, 3i and negative 3i, and 1 real at 5. So let's write this out. X minus 5, x minus 3i, and x plus 3i. Remember I said my hint was to multiply out the ones that are similar or opposites first, because that's going to cause some cancellation. Otherwise, you're going to get like a positive 15i, and that gets really gross really fast. All right, so we have x minus 3i, x plus 3i. So x squared, this would be negative 3ix and positive 3ix. So notice those will cancel. Then we have negative 3i times 3i. So that's negative 9 from the coefficients, I squared. Okay, now you might be thinking, what in the heck is I squared? But we know that I equals the square root of negative 1. So I squared would equal the square root of negative 1 squared. So that's just going to be the square root and the squared will cancel out, and that's just going to be negative 1. So this turns into negative 9 times negative 1, which is a positive 9. Okay, so that's x squared plus 9. And think about if you were to set that equal to 0, x squared equals negative 9, and take the square root, positive or negative, that would give you a positive 3i and a negative 3i. All right, so then I still have, sorry, that should be a minus 5. And then I'm just going to multiply those two out, and that should be just like what we did on the previous page. So x minus 5, x squared plus 9. So x cubed minus 5x squared plus 9x minus 45. And there's no like terms here because one was a quadratic and one was linear. So x cubed minus 5x squared plus 9x minus 45. Cool. All right, same thing for number 12, and then we're just going to do 13 and 14 in factored form. We won't multiply them all out. All right, so first factored form, I have negative square root 6 and positive square root 6. So x plus square root 6 and x minus square root 6. And then if I have a positive 2i or 0 plus 2i, I'm also going to have 0 minus 2i, which I can also represent as negative 2i. So this is going to be x minus 2i and x plus 2i. All right, so first two terms, I'm going to go ahead and erase this stuff right here. Again, group them in what's similar but opposite of each other. So we have x plus square root 6 and x minus square root 6. So x squared, square root of 6x, negative square root 6x, so that will cancel. And then negative square root 6 times positive square root 6 is a negative square root of 36. Or I can represent that as negative 6. All right, so my first one turns into x squared minus 6. Then the second one, x minus 2i, x plus 2i. So x squared, we know those are going to cancel out. And I have negative 2i times positive 2i. negative 2 times negative 2 is negative 4, and I times I is I squared. So I squared, we know I is the square root of negative 1, but then I'm going to square it. So square root of negative 1 squared is just negative 1, like we did in the previous example. So this turns into negative 4 times negative 1, which is a positive 4. So this is x squared plus 4. Then lastly, you're just going to multiply those two quadratic binomials by each other. So f of x equals x to the 4th. Then you're minusing 6x squared, but adding 4x squared, so that's minus 2x squared minus 24. All right, for the last examples, we're just going to write them in factored form, and then you'll have a chance to write them out in standard form. So x minus 2 square root 5, x plus 2 square root 5, and then if I have a negative I know that I have to have a positive I. So x minus I and x plus I. And you can practice multiplying those out. For the 2 square root 5, just go back to what we did on the previous page with those 2 square root 3s. All right, last one is a little bit trickier. So I know I'm going to have x plus 4 to represent that negative 4, and then I have 3 plus I, so I also have to have 3 minus I. Okay, now you're always subtracting with your roots. So really, I could have represented this as x minus negative 4. I just know that that turns into an x plus 4. So x minus 3 plus I and x minus 3 minus I. Now, that's a lot of parentheses going on, okay? But just big idea here is you're always subtracting your roots, okay? I'm going to go ahead and distribute that. So that's x minus 3 minus I, just distributing those negatives, and x minus 3 plus I. You can still do what you did before with a box, but this time if you're multiplying these two together, it's going to be a 3 by 3 box. So let's actually do this one because it's a little bit different. All right, so 3 by 3, x minus 3 minus I, x minus 3 plus I. So x squared minus 3x minus ix minus 3x plus 9 plus 3i, ix or xi minus 3i minus I squared. All right, so a lot going on, but a lot's also going to cancel. So I have ix and negative ix. I have 3i and negative 3i. The only thing I do need to clean up is this negative I squared. So we know I squared is square root of negative 1 squared, which is just negative 1. But be careful, don't forget that other negative. So a negative times a negative will give you that positive 1. So combining like terms, I get x squared minus 6x, and then 9 plus 1 will give me 10. So it looks really gross at the beginning, but it's going to multiply out into a nice quadratic. Don't forget, for your final answer, I'll leave you to do this part. You still need to multiply that by x plus 4 because you have a root at negative 4. Okay, so that kind of gives you an introduction to slash review, because you should have seen this before, to complex zeros, working with imaginary numbers, and all of that. So hope that made sense, and have a great rest of your day.